Thank you very much. Thank you, Pavan, for the invitation. I'm thrilled to be here. This is my first time at Yale. I've heard a lot about the university. I've heard a lot about the course. So I'm obviously very excited to be here. And when Pavan talked to us, to a few colleagues of mine, I know you met Andy Rosenberg last week, or actually this week, when he talked to us, and we were discussing the things that we were going to be talking here today. My role would be to talk about Chapter 5, which is payment for ecosystem services. And my current position at CI, I'm a scientist that works a lot with ecosystem services, valuation and mapping, and looking into the landscapes and how we can inform the field activities that we have. So for that reason, I'm going to try to give you a flavor of what the science, the applied science of ecosystem services is for a large organization like ours, and how we implement some of these activities in the field, the hurdles that we face, the challenges, but also the successes that we've had in the last 10 years or so. So let me start by, oops. So this is, let me start by talking about a little bit of the outline of this presentation today. I'm going to talk a little bit about our work at Conservation International and the reason why we care about the science and implementation of ecosystem services. I'll be focusing in the next few slides on the science of mapping ecosystem services and valuing ecosystem services with a specific goal of informing policy and decision-making processes and our implementation in the field. And then I'm going to be talking about some of the tools, some of the cutting-edge tools that we are working to do this analysis. And then at the very end of the presentation, I'm going to address some of our field experiences, some of, scaling up of activities from the very local level to a more national level of implementation, and some of the successes that we have obtained in the last years. So, oops. Let me start talking about CI. We were founded in 1987, and historically our main goal has been biodiversity conservation, and we've done a lot in the last over 20 years working with that. But in the last few years, I think out of awareness that though we did feel that quite a lot was accomplished, we also realized that there was much more to be done, and extinction rates continue to grow. And we would only get so much done if people weren't aware of the importance of ecosystem services for their own livelihoods, for their own well-being. So a few years ago, in a major change for the organization, we changed our mission to one that is a more encompass of human well-being, in a sense that our needs a lot of our needs come from nature, and unless we care and protect nature and ecosystem services, we are very much undermining the health of the planet and our own health. So that's very much what's driving the organization now. We are working very much with security. So we are looking to climate, fresh water, food, health, security. So it's a big shift for an organization that it was, as I said before, focused on biodiversity conservation. And one of the impetus was also a report that came just a couple of years ago in this middle of discussion about the role of ecosystem services and for the purpose of conservation, of nature conservation. This report was done for the Beth and Gordon Moore Foundation, and basically what they said is that although very promising, the concept of ecosystem services had really a long way to go in terms of getting standards and robust methodologies for assessment. And unless we did that, we really wouldn't have the concept internalized in all levels of decisions and in all economic sectors. So this was, an important conclusion of a report that made all of us even more aware of the challenges that we faced, and but also had the very positive note that it is a very important concept, and it is one concept that a lot of conservationists, a lot of researchers are very enthusiastic about, and it has the great potential of changing the way we do biodiversity conservation. So, speaking about the standards of measurement, so what are the difficulties that we face? One thing about ecosystem services is that they are not homogeneous. They are very heterogeneous, and they also evolve with time. So both in space and in time, they differ. They have very specific characteristics, and so they require us to look into not only where the biomes are, but look into climatological issues, geomorphological issues. So it's a fairly complex science of looking into different ecosystem services. This, basically the location is driven, the location of those biomes is primarily driven by energy flows. And at the same time, so unless we really understand the specifics of the different ecosystem services in terms of how they occur in a space and how they flow, most importantly, in a space, then we won't have a good grasp of the services and how they reach humans and how they provide for the benefits that we are talking about. So one of the things that it's really not that new, but it's still a problem, and it's still a hurdle that we face, is that in trying to look into different ecosystem services and see how these ecosystem services reach the beneficiaries. In this diagram here that I'm showing, you can see that in the number 1 quarter there, you have the provision and the benefits occurring at the same site, at the same space, in the same cell, for example. This is, let's say, provisioning services like food service, or subsistence agriculture, where the services are there, the population are there, the services reach the beneficiaries at the same unit, at the same spatial unit. In the second one, you have the provision that occurs at a certain space, but it has a much broader impact. It's like the case of global services like climate regulation, the role of forests, for example, in regulating the climate. So it's a more omnidirectional benefit. In the third one, you can see, for example, where the services flow downhill. This is the case specific of water, for example. You have forests upstream that have an important role in controlling flow and quality of water, as an example. And the last one, you have, say, coastal services, like think of wetlands, coastal wetlands, estuaries, whose the provision occur at a very edge, but the benefits are reaped towards, the other side, one direction of benefits. So this is really what we need to keep in mind for different services. And this is what we started looking into and thinking about how do we go about and map this in a landscape, in an area that we care about. How do we look into whether there are synergies between biodiversity and other services? How do we look into where are the best areas to invest, considering that we have limited conservation funding, and we want to be efficient and cost effective. We want to, we have so much funding, we really need to address the areas that are under the highest threat, and we also need to address the areas on which we can afford to work, So what we did is we started mapping in the island of Madagascar, a very important high biodiversity, a mega biodiversity area, which has a tremendous amount of deforestation. Less than 15% of the forest remains in the country. So we looked into Madagascar and thought, are there synergies? What do, can we see biodiversity co-occurring with other services? So we looked into biodiversity, and the next thing we looked where climate regulation in the form of biomass, both above and below ground, was found. And remember, this is a service that's omnidirectional. So really, where it occurs, it's distributed evenly across the globe. The next thing we looked into was water. That's the very specific case where really it's a benefit that addresses the needs of local populations. So in our modeling, we looked into areas downstream that were dependent on water, both for consumption, household consumption, as well as for rice paddying. So we were looking for quality of water, water free of sediment. So these is the results. You see the red areas are areas that are very important for the provision of water services downstream. The next thing we looked into was, so now we see there is biodiversity, there is climate, there is water. Can we bundle them? These are areas where you can find a certain level of the provision of these two services plus biodiversity are certainly areas you want to look into investing your conservation funding. So these were the areas, the eastern fringe of Madagascar, that's where most forests exist, the primary remaining forests exist. These are the areas that are then where we can bundle the ecosystem services. The next thing is we looked into was which are the areas with the highest threat, which areas if we model deforestation for the next...
Sorry to interrupt, but just perhaps you could explain, when you looked at water, you looked at only the quality but not the quantity of use?
We did look at both water quality and quantity. I focus on quality, but yes, we did look into quantity as well, because the population downstreams are dependent on the flow. Yes. The question was whether we looked into quantity or just quality. We looked at both. The next step of the analysis is where the highest threat is found, because those are the areas where we want to address our efforts. And this is the results of our PROBIT model on the highest levels of deforestation. Note that it doesn't really occur on the eastern fringe, but we found it more like on the western fringes of Madagascar. The next thing for us is, okay, so we want to add the concept of additionality. I'm sure all of y'all have heard about that. It's a very important concept. It's an area where you want to act, because otherwise the benefit will be lost in terms of the provision of ecosystem services. It's a concept that is used a lot in the REDD+ mechanism. So areas on which, if you don't prevent deforestation, those areas are most certain to disappear as a result of deforestation. So we bundled this, we overlaid or we multiplied the results we had from the bundle services with the high threat areas. And the last step in the analysis was to look into the areas which essentially any investment, the opportunity cost would be too high for us to meet. So what we did is we subtracted the high opportunity cost, which in the case of Madagascar is primarily cash crop for exports. So we subtracted those areas for the analysis, and the results that we have here is basically where are the efficient in terms of addressing deforestation and cost-effective areas for implementation of potential schemes, potential payment schemes. In reviewing the Chapter 5, as I'm sure you have, you notice that one of the main issues in implementing a payment scheme is oftentimes the lack of targeting, the lack of the targeting from a spatial perspective in terms of are the services provided, is there a threat that we can address. So this kind of exercise is a preliminary step that addresses this question. Of course, there are other institutional issues, other socioeconomic issues that really need to be looked into, and I'll talk about those eventually. But this is just an example of how we went about. Now, I'll talk very briefly about one exercise that we did in terms of looking into values. Like this, in this case, we are looking to global values of ecosystem services. We are looking into one area that is relatively new for me personally, is like coastal and marine services. We normally focus a lot on terrestrial services. We are now doing a study that addresses the global values of fisheries, recreation, tourism, and shoreline protection. The results of this analysis have just been finalized, have just been produced. But what this kind of analysis show using different methodologies is that some areas really have very, very high values in which we want to focus our effort on, and that has some implications for policies in terms of, let's say in the case of fisheries, where the benefits go and where whether local people are getting those benefits. I'm not gonna really dwell very much into that because, because the main purpose of this, addressing the issue of valuations, as I'm sure you already have seen before in the presentations before, is that the valuation remains a fairly controversial issue, as you all know, but one that is extremely necessary because when you make decisions, you really rely on information. There's no perfect information, there is no perfect world, but you really have to have a minimum amount of information. So we do valuation at a global level to have a good picture of how, what the main areas, and oftentimes we delve into some specific areas to look, some specific countries to see, what the values are for the local economy. But the main point of this is just to tell you that this is all very well and interesting, but, what is the ultimate goal? What is the ultimate goal of a valuation exercise? It's decision making. And how do you go about, what kind of information and what kind of decision making, what kind of indicators can help us to really incorporate the natural capital values into these indicators that are more widely accepted. We economists, ecologists, we often provide single, point site analysis or global analysis that I just described, but they remain they remain a study that was done that showed the value of these ecosystem services provided by that biome is such. The challenge now is how to move on into this macroeconomic indicator that will tell you that the natural capital values need to be incorporated, so we get more and more aware of how resources are being degraded, and we get more and more aware of our dependence on natural capital. And what we currently have in our macroeconomic system is just a matter of the main macroeconomic indicator is GDP, which is a broad measure, is the value of all markets and the market goods and services in a country in one specific time. But this GDP has enormous limitations, and one of the limitations is it doesn't address distributional issues. As we know, it doesn't address the issue of the degradation of natural capital as it does with other physical capital. So in order to overcome that, one of the potential alternatives is looking into incorporating natural capital values, or specifically of ecosystem services, into a national accounting system. And there are quite a few initiatives that are doing that. One important initiative that I hear you're gonna discuss that in more detail eventually, but I'm gonna just briefly introduce, is the World Bank Wealth Accounting and Valuation of Ecosystem Services that is led by the World Bank in partnership with a number of organizations, and is piloting these exercises in 6 countries. Colombia, Madagascar, the Philippines are just a few of them. And next, working very closely with the United Nations SEA, which is the System of Environmental and Economics Accounting, is trying to set up the standards for incorporation of ecosystem services values into national accounting. This is all to introduce you to the work that we are doing in Madagascar. Again, under the scope of wealth, we're looking into one very important area in Madagascar, which has the acronym CAS, and doing an assessment on the biophysical and monetary values of ecosystem services, and looking into how from a site level analysis we can upscale those values to a national level system. So this is a very preliminary study. I'm heading to Madagascar next week for a field activity, data collecting and talking to a lot of policymakers about their needs, and looking into how they have managed so far to implement some of the payment for ecosystem services schemes and some of the lessons learned, with the idea that we can get using one modeling tool, we can then produce biophysical and monetary values of ecosystem services in Madagascar. So, moving on, one of the tools that we are using in Madagascar, and to a great extent, this is helping us to see the validity of using that tool, is ARIES. I'm sure many of you are familiar with some of the tools that we currently have for mapping and valuing ecosystem services. The work that I showed before does not rely on any of those tools. They are basically results of statistical and our own modeling, hydrological modeling included, using important GIS data, important land-based information. With those tools that we have, and the 3 of the most prominent tools are INVEST, MIMES, and ARIES, we can do in a more effective, in a more systematic way assessment and valuation of ecosystem services. Let me start with INVEST, and I just have to say that my work is with ARIES, so I'm going to focus a little bit more on ARIES, but I can say a little bit about the 3 of them. I'm somewhat familiar with the 3 of them. ARIES is a natural capital project, which is led by Stanford, the Nature Conservancy, and the World Wildlife Foundation. And it's a very prominent tool in a sense that it uses spatial modeling. It uses, basically, it's a set of tools that is very modular. You can do different things. You can add or you can build as you go. And those models are deterministic, which means that they're basically based on equations. There are algorithms, as we like to call, that determine the provision of a service in a specific landscape using GIS-based information. So this is available on this website, and what you do is you download the system, and it's the premise of INVEST is that it's a decision-making tool that allows for policymakers and decision makers to see different scenarios that are primarily based on land cover change. So think about a forest versus a non-forest areas, you know, for say an infrastructure or you know, any kind of mega change or mega structural project or infrastructure project. So this is what INVEST can be used for. Again, it's modular in a sense that you can do hydrology if you want to focus only on hydrology, or you can do other services. They have quite a number: climate regulation, pollination, and they have quite advanced quite a number of models. Again, this tool is a model that relies on algorithms, and the requirement to do an assessment on a specific area is basically that you do understand GIS, you have a basic to intermediate level of GIS, and also that you need to get the data set that the modules require. So it's quite intensive in terms of data sets needs, which are GIS layers of data sets. Very interesting tool. They have case studies in many parts of the world. It's a prominent tool. MIMES is it's a static tool. So you see things now. You have land cover change. You can see what the results is, but it's like the scenarios are static. MIMES, on the other hand, is a dynamic model. It is based on simile, which is also deterministic, also based on algorithms. And what you do is you have to have a very good understanding. And this is a University of Vermont model led by the Gunn Institute for Ecological Economics. And almost all models for all ecosystem services are developed. It can also be modular. And there you have a library of models, but it requires that you do have a fairly good understanding of modeling in order to get an assessment of a certain area. It also requires a significant data set, and I think one of the most limitation is computational power. It really is demanding because it's run on a cell-by-cell basis, so the whole model runs in a cell, and the flows are determined accordingly. So it's a more say sophisticated in a sense that it requires a good understanding of modeling. And then there is ARIES. ARIES is the result of a National Science Foundation grant that we got a few years ago. And ARIES is not exactly a model. He's basically done with Bayesian networks, and it's not based on algorithms like the other two. It basically uses intelligent systems to build specific models as you go. It's also available on the web, and you can basically select any specific area of interest and then do an analysis. The caveat is ARIES is a tool in development, so there are many models that are created, but it's certainly not as well advanced as INVEST in terms of easy access. You will have to go and you have to work, most certainly would have to you could select an area, and you most certainly, if you're very serious about doing an analysis with ARIES, you most certainly would probably need some guidance or some fairly good understanding of how you could do that. We have a number of case studies. I'm just trying to convey the message that this tool is in development, and it's probably the most cutting-edge tool amongst all the other tools. So it's certainly more sophisticated in a sense. Go ahead, please.
It's a form of Bayesian network modeling?
It's a Bayesian network modeling, yes.
And is it true, I only know a little bit about Bayesian network modeling, but is it true that the strength of your model is determined by kind of the certainty of your inputs, the strength of your inputs, and how robust you're able to build those kind of information
The question is about the robustness of the models in terms of whether it depends on the inputs. I think that's true for all modeling tools to a great extent. But in the case of ARIES, I think the uniqueness of ARIES is the fact that it has a probability function that will allow you to run the model irrespective of you having data for specific parameters. With the other two models that we were discussing, if you don't have data for a certain parameter that is crucial, you basically won't be able to run your model. With ARIES, you're able to run your model, but your results will have a certain probabilistic result, will have the level of certainty or uncertainty is higher. And so, you know, for the other two models, remember, they are deterministic, which means that the results are the results. And so it's a matter of you to trust whether you know, the algorithms of the model are correct. Another question?
Yeah, well, just building on that, I think Invest allows you to work with different tiers. In the sense that you have the first tier is like the most basic one, and then you will be able to, with little information, do like basic planning decisions. And then you have another tier which is more complex, and then another one. And you can go back and forth to another one.
That is true. The question was, the Invest has a more tier approach or characteristic, if you will. And so you can choose the level of complexity as you can choose the modules that you work as well. And Invest also for the tier 2, which has been released not too long ago, you can also do economic valuation of certain services. It's not, unlike some models, it's not benefit transfer. The economic valuation there is more production function approach than other models. In any case, I can move on and talk a little bit more about ARIES. Are there any other questions? Yes.
Just a brief question about these probability functions. Is that based on Monte Carlo, Markov chain Monte Carlo approaches, or?
I wouldn't know. I'm not the person who's doing the modeling of it. I can put you in contact. The question was whether it's based on Monte Carlo. I wouldn't be able to answer that question. Of all of these three models, I have to say that I probably worked a lot more with the MIMES approach. I'm a co-PI on ARIES, but it doesn't mean that I'm working with the modeling process. I'm working more with the applications of it. Okay, so moving on, we do have a few characteristics, I think, that will better explain what ARIES is about. First of all, it's, So let me go back. Okay, it's a toolkit. And it's not a single model, as I said. It's not deterministic. And it's based on an intelligent system, which means that the data, it's based on what we call, it's based on our latest understanding of ecosystem services and the variables that are important for the provision of a certain ecosystem service. And so there is a lot of background information, but once the data sets are, and we are talking about globally available data sets in this case, the model has an ability to learn from the data sets and to establish, through Bayesian networks, to establish the correlations. So no algorithms either. I think the most unique thing of ARIES is its ability to not only address the provision, which is what the other tools offer, but also the benefits and how the ecosystem services flow in space. Remember, this was at the very core of my talk. How do you address that? How do you avoid the spatial mismatch in terms of provision of benefits? That's by far, I would say, the best characteristic of areas. The models allow for the flow of ecosystem services in a certain landscape, which means that we can assess how they reach beneficiaries. Another thing is that we just discussed is the fact that it's a probabilistic model, so there is a degree of uncertainty associated with that. So the results of the two are not, a single number, but rather, it will provide you a range within a certain value that the results are. And all of those results, like the other models, they are spatially explicit results naturally, and you can see maps of it. It is a web-based, it's not proprietary. It's basically can be accessed by anybody. Remember, it's a tool in progress, so the computational power of it is still somewhat limited. And so we basically work on a series of case studies, and like I said, the example in Madagascar, we will use areas to model the biophysical flow of ecosystem services in the CAS area. So this is at the core of areas. This is the conceptual framework. As you see in this green area over here, you have a biome or a certain area which provides ecosystem services. Let's call it the provisioning region. The beneficiaries of those services, let's say for the sake of example, are downstream. Let's talk about non-rival use region. And so as the ecosystem services flow in space, you can have some sink regions, which can be a good thing or a bad thing. A sink region, for example, when you interrupt the service, when you build a pipeline through here and you interrupt the service, is certainly a bad thing. A sink region, when you provide for retention of sediments, on the other hand, can be a good thing. But that's the concept, that ecosystems flow and services come not, it's not from the purpose of decision making. It's not only important to find out where the services are provided, but rather where they reach beneficiaries. Moving on, so this is another way to express that. Let's think about the landscape, and these are pictures in Madagascar where you can see provision of services of biodiversity in a certain landscape, and you can see the activities that are dependent on those services, being rice paddying or ecotourism. So these are the areas where the beneficiaries are located, and so we need to model the flows between the provision and the services and how they reach the beneficiaries. So this is definitely spatial modeling at its best. So because, like I said before, different services will have different ways that they flow in space. For example, hydrological services, they basically they follow well-established hydrological models, and so that depends on the topography of the region. For static view sheds, for example, the view of a mountain, it's basically the line of sight, how you can see it. For climate regulation is omnidirectional, which means basically a service provided here benefits the entire globe. And for recreational, it's more like a curve kind of function that the farther you are away from the service, then the lower the benefit is for you. So here you have one specific, for example, output of areas. And this is the Puget Sound in Washington State. And what you can see here is the critical flows of services. So think of this area on the left hand side, where you can see there are these contour circles that determine which areas are really critical for the provision of services, and in which any effort should be made to leave that area relatively intact or even enhance the services or enhance the protection of that area. So the closer do you get into this contour to the red circle areas, these are the areas that any disturbance in those areas would basically create the major disturbance in the flows of services for a number of beneficiaries. This is important because suppose you're citing a pipeline over here. So you certainly want to avoid the critical areas. So there are ways that you can plan to avoid the critical areas of services flow. This is another example that we had for areas in Madagascar that focus more on fisheries, so subsistence fisheries. And what we did in the first map was to look into the demand in terms of coastal populations that were dependent on subsistence fisheries. And I apologize, it's really hard to put maps on PowerPoints, and at least in a way that you can see the details, but I'll be very happy to, should you be interested in getting better maps for you. In the second one, we have a fraction where the demand is met, on which people have access to the fisheries. And in the last one, we have where the demand is not met for a number of reasons. You know, sediments could be a reason, lack of access could be a reason, excess population could be a reason. But all to say that with a tool like that, you really can pinpoint areas that are important on where you know, we need to look very carefully and see what's going on. So like many other tools, this is a first approach to understand at the landscape level where the issues are. But as I said before, for policy and decision-making process, you certainly need to go one step ahead and look into other socioeconomic contexts, institutional factors, presence of absence of government, etc. This is the result of one case study that we did in Veracruz, Mexico. And that also illustrates where different, you know, the different needs by different sectors, not only different populations, but here you can see demand of water. This is an area where there is water scarcity and there are conflicts with respect to water uses. So we looked into this area, we looked into the different conflicting needs from agriculture, aquaculture, industrial, residential, and we could find out what the demand was, and then doing an areas analysis, looking to where the flows to beneficiaries were, and then the results, which were basically sources that could be usable, sources that where you had surface water, but sources that you basically didn't have access to water, you know, basically because surface water was not present, or you know, any of those issues. We most of the hydrological models that we work are essentially based on surface water. Groundwater remains a very difficult issue to address. There are no data sets. So these are data sets. A lot of those data sets behind here were customized working with INECOL, which is a Mexican agency, and some of the local stakeholders. We did a fairly good participatory process with them. We did the models. We worked with them in getting the data. We went to talk to them about the preliminary results. We are now in the process of getting the feedback incorporated into the analysis.
Sorry, will you just briefly explain the couple of the images there? The image on the bottom right-hand corner, what is that?
The right, which one? No, the bottom.
Multicolored image on the right-hand side, what is that?
Can you read it for me, please?
It says inaccessible water source.
This is where basically there is no water, or water that can be accessed. It's either groundwater, but you can't really reach, or it's not on surface water, or people do not have access to water in this region.
And sorry, presumably the red means where it's least accessible and the blue is most, is that?
I'm sorry?
What do the colors represent there, the color codes?
I should have here a diagram, but I think the red, the areas, these are more critical areas. These are the areas where you face a scarcity of water. So from yellow to green, this is, and on the blue lines here, this is higher areas. So they are probably, you know, there is a little bit more access of water here than further down. Yes, please go.
So it's not counting an infrastructure?
I'm sorry?
Is this not counting an infrastructure?
No, this is basically, there's no issue of infrastructure here. This is basically, we're talking about water flows in the landscape and water needs, and where water meet the demand or where it doesn't meet the demand. Is there another question? Go ahead, please.
Is there a major difference between the possible source and actual surface use? I can't really see that.
Yeah, I'm sorry. This, you would need to see the maps, and I agree that the color scheme. The possible source is where you could, essentially, there is a potential for you to reach that water, but for some reason you don't. The actual source is where there is water there and you can reach there, and you are reaching there. You're using for some consumption, being that industrial, agriculture, or human consumption, household consumption.
In this study, did you see a significant gap between these two?
What I think one of the results of the study was the differences in terms of what the needs were and in terms of what the demand was. So the conflict is, you know, whether water is taken for a specific use in a certain area, let's say industrial use, and will leave less for local populations, that kind of, this kind of conflict. So you can see where in the landscape, you can see where the water is used for different purposes and demand is met or unmet. Okay. So we do have quite a few case studies that we have developed and in different stages of development. I'd say probably Washington State, Madagascar are fairly well developed in terms of the services. Veracruz is also had a very strong focus on water, so it's fairly well developed in that sense as well. But it's a tool that has very limited funding as well, and it's a tool, as I said, I'd like to stress that it's a tool that is being in the process of being developed. So there are a lot to, there is a long way to go. I've been talking about those tools to model, but I think I didn't want to just, you know, give the impression that, you know, you really have to have a lot of technical expertise or, you know, that technical background to do those ecosystem services, which is often, you know, what happened. You have a group of people who are fairly familiar with modeling or fairly familiar with the use of GIS. In some cases, you do, when you can't do that in other areas, you really can rely on other important tools that are available, and there are also based on spatial data sets, on remote sensing data. And those tools, though they are not ecosystem services, they can be very informative of where degradation occurs. And I'd like to point the fire risk and the fire alert system as tools that are very important in our field activities. And the illegal logging and encroachment also as a tool that it's very important in the use of protected areas and REDD+ sites. So these are tools that you can look online and you can subscribe to the service, and you can, as a manager of a certain area in a remote area, you can monitor either fire, the occurrence of fire or the risk of fire, and you can also monitor encroachment, which is really very important. It's not available in all countries, but our efforts are focused on mostly tropical areas, Madagascar, Indonesia, Bolivia, and Peru, for example, for the fire alert system. For the fire risk, it's a more global tool. Illegal logging at the moment is currently restricted to protected area and red plus sites. And we get amazing feedback from the use of those tools, because really through a subscription service of the tool, you can really get an alert in the form of an email. You can act. So, like I said, there are different tools, they have different purposes, and they are always very helpful, especially for forest service of the countries who have very limited capability to monitor that and to enforce the law. I will wrap this up recalling what I said at the beginning with the lack of standards and the lack of monitoring tools, the lack of decision-making tools, which what I was addressing before. So we are currently now working with a group of organizations and scientists into developing some standards for the regular monitoring of ecosystem services. We do have a site in Tanzania, which is what I'm showing here, in which we are developing and testing metrics for ecosystem services tools, agriculture, livelihoods, and climates. This is very much work in progress and at the very early stages, but we are in the process of negotiating, upscaling this to the African continent and the global as well, hopefully with support from the Gates Foundation. So this is very exciting work. I'd like to shift gears now and talk more about payment for ecosystem services. I spent quite a bit of time talking about the science of ecosystem services and the tools. Let me talk about one important portfolio of projects that we have that is called Conservation Stewards program, which we have in 9 countries with over 50 projects. They are essentially agreements with communities to protect biodiversity in exchange for economic benefits, sometimes in the form of livelihood improvements, sometimes in the form of cash payments. They vary. But so through this project, it's really quite amazing. We do have, like I said, over 50 projects, and I think we reach out more than 3,500 people around the world with this project, oftentimes working with communities. One of the projects that we had was in Ecuador called Gran Reserva Chachi. We worked with 3 indigenous communities, and we provided basically monetary compensation for benefits which were commonly agreed upon by the communities, and in exchange for enforcement and protection of a fairly small area, 7,000 hectares in the Choco region. And building this project, and I think one of the papers that you had explained very well, all of these projects require not only a lot of studies to find out what the benefits are, at a minimum in terms of biodiversity conservation, if not ecosystem services, but a lot of building trust, a lot of negotiation, these are contracts, these are agreements in which the communities and conservation organizations like ourselves, they enter into a contract to do that. So we did that with a number of partners. We often work with several partners. We have a great number of partnerships around the world. And this was just, a few years back when this was going on, people would say, well, that's a fairly small project. This is kind of, very low key, but the importance of this project, it's really that it provided the foundations for a much broader payment scheme that is now being implemented in the program Sociobosque in Ecuador. So Ecuador has this project that reaches quite a number of people, impoverished communities, and it's very much for the purpose of biodiversity conservation. Also is one of the strategies of the climate strategy of the country in terms of maintaining the carbon stocks in the area. And it's a fairly ambitious project, and so far fairly successful as well. I think thus far they have reached something like, I can't remember what the numbers were, but thousands of people have already applied and are already receiving the benefits. I think something like 8.85 million already was spent on this project. And it's really has a lot of the social goals, political goals, if you will, that many other projects don't have, specific with the target of addressing poverty alleviation. So this is a fairly unique project in many ways, and one that we have great hopes for so far, has been quite successful, as I said. I will go on and talk about reduced emissions from deforestation and forest degradation. We do have also a good portfolio of 20 projects, more than 20 projects. They are either in the process of being implemented, or they are in the process of being designed, and they are spread all over the world. And our main role in those projects, oftentimes we work very closely with the government. These projects are implemented by the governments, is to provide the technical capacity and the ability of those countries to implement, both by being ready to implement their climate regulation strategies, to implement their baselines with very solid, robust methodologies that will establish what the emissions are expected to be, and also training people in the field to do that, building capacity in those countries. So this is an example of, for example, the kind of mapping, the kind of modeling that we do to both find out where deforestation is being historically occurring, and to model, to predict the future deforestation in the absence of the project. So we do, that allows us that, rigorous scientific assessment that follows approved upon standards, allows us to work closely with these communities. Peru, Colombia, Panama, Kenya, PNG, and Cambodia are in the process of having feasibility studies, of working on the project description and design of these documents, and doing further research on the advantages of reduced emission and of deforestation and degradation. That's also very important, as a very important convincing argument. There is a tool that I won't be talking about, but you please do take a look. It's called OSIRIS, that allows national governments to play with different sets of RED plus designs to find out the economic benefits for their country. And in this case, for example, we have a very good study in Indonesia that shows very clearly what the economic benefits are. Let me talk about Madagascar once again, because this is an area on which we have put a great effort in addressing the issue of degradation. As I said before, I've been working in Madagascar for many, many years now. And in 2003, the president committed to triple the areas of protected area in the country from the current levels then. And so that meant that we, working with the government, we were able to, going through a very important participatory approach, determine the design of this large landscape area on which we would focus efforts to prevent deforestation, creating a major protected area that would encompass a mosaic of different land uses, some with strict conservation and some that were on which human uses were allowed. So this is what CAS is about. In the light blue areas are formally protected areas, either national parks or reserves. So we have here, this is probably one of the largest rainforest tracts in the country, with an amazing biodiversity in terms of the species that are found nowhere else, endemic species, and particularly lemurs, which are fairly threatened. That has also a fairly large population density that relies on livelihoods that are slash and burn agriculture primarily. Some other as well, some other degradation issues are resulting of mining, logging, hunting, and wildlife. So working in this area, we are able to design this REDD+, which has the purpose of reducing emissions, but allow to really this area to be effectively protected and implemented, the CAS area. We are working with the World Bank, which has committed to buy some advanced, purchase some advanced emission reductions from the area. But the most important thing about this, and most important message, is that this is only working because we are working with a management system that really allows for great participation from the design of the area to the decision level making process that involves local communities. So it's really rather impressive. You have from the highest levels of the government, from the minister to the manager of the area, to the population living in the different sectors, who not only have employment opportunities, livelihood opportunities, but also have a say in the design and implementation of the project. And I think that's basically probably the only way for these activities to succeed is to have a buying in by the local communities, a participatory approach that allows to people to voice their concerns and their needs. We are also working very hard on building capacity, as I said before. We have trained a good number of people. What you're showing here, this picture is just a training a couple of weeks ago in Madagascar. And we are now doing a university level course similar to what you have here on REDD+ in Madagascar. I'm going to now wrap a little bit this talk talking about our lessons learned. A couple of years ago, a colleague and I did a review of our initiatives on ecosystem services and payment for ecosystem services schemes around the world. And we really found some very interesting lessons and insights from our portfolio. First, we really realized that we really need more science. We really, many of the schemes that you come across are, a lot of them are based on assumption. You see that in the literature. So you really need to address more, the issues of provision, benefits, additionality. And we certainly hope that the exercise we did can shed light into that. We need more spatially explicit tools. I think they are becoming more and more available, but they're still fairly sophisticated and fairly complex. We need to make sure that we can, using those tools, convey the message in a clear, compelling way, with the robust science that we want to see, but in a way that allows for the impact to be more easily observed. We need to really care and address socioeconomic and ecological context. I think we as scientists, we very much focus on the biophysical and the economic side, but not so much on the social. I think participatory approaches have proven to be critical and quite important in the success of the into these agreements. So as is the stakeholders' participation that I hope I have emphasized. Again, we really need a lot of science. We need to tailor for the different context. Each agreement is a whole new world in terms of building trust, in terms of negotiating with communities. And I think in one of the papers that you were given, you really see that, you know, sometimes this trust can be rather personal. And so people feel, you know, it takes time, of course. You can do that in a paternalistic way. And so sometimes even the project can be a little hindered by the absence of a person if the trust is very much associated with that person. I think one of the main issues remain funding. This is nothing new. We often fundraise for our projects, and you know, the fact that we don't have a stream, reliable or consistent funding is certainly a major limitation of this project. But so is the fact that in often cases we focus very much about only one aspect of the area, and not, you know, only, for example, focus only on one, you know, the biodiversity, but not on other benefits that could make the project more viable in the long term. This is basically what I'd like to say. I think there's quite a bit of information, and I apologize for having packed so much, but I certainly hope that we can talk. And once again, what I presented here is not only my work, but the work of a lot of my, you know, a lot of people I work closely with. So in many cases, should you have a specific question, I'll be more than happy to put you in contact with my colleagues. And I guess this is it. Thank you very much.